Hey, you guys, I realized after I made that last video, I never really explained why Rolle's theorem is a special case of the mean value theorem. I said I was going to, and I never got back to that. So let me do that now. This is like one of the joys of math. When you see that like a formula or a theorem is actually a special case of something bigger, and that bigger one captures the other one and includes so many more cases. So what's going on here? So Rolle's theorem, right? Rolle's theorem has the three hypotheses. The last one is not included in the mean value theorem. So what is it, right? It's when when we require f of a to equal f of b, the y values of the endpoints have to be equal. And the conclusion of the theorem is that f prime of c is equal to 0. Okay, now let's skip ahead to the mean value theorem, and we get rid of that last hypothesis, and we get this larger formula for what f prime of c might equal. Well, think about it, right? If in the case that f of a is equal to f of b, what would happen? Well, all of this would be 0. And so hence, you get rid of that, and all of a sudden, we still do have a result, but it's something even bigger and captures the other one. So amazing. Okay, a little bit more to it. We could even think about it graphically, right? Like in this first graph down here, the mean value theorem is when you connect the endpoints, and you think of what is the slope of the line between the endpoints, right? And there's got to be some value of c where the slope of the tangent line, or I should just say the tangent line, is parallel to that line between the endpoints. Well, what if those endpoints had the same y value? Then the line connecting them would be a horizontal line and would have a 0 slope, of course. And so Rolle's theorem says, well, then there's some value in between it's still parallel to that line, just happens to be horizontal, and so the slope is 0. So there you go. Now you might be thinking to yourself after this, like, all right, well, yeah, Rolle's theorem is a special case of mean value theorem. Well, then why do we even recognize Rolle's theorem? Why does it have significance? Why don't we just talk about the mean value theorem? Because that would obviously capture all those other cases. Truth is, I don't know exactly. I don't really know the history of it or the use of the two theorems, but it could be that Rolle's theorem, it just has enough use in itself that people find that it is worthwhile to keep it and to recognize it by its own name, just so they can easily reference Rolle's theorem, because it gets used a lot for whatever purposes, I'm not exactly sure. So just for the sake of convenience, in the case where, that the slope of that, the tangent line of that particular point is 0, that just has enough usefulness in itself. Which one came first? Again, I'm not really sure. It could be that Rolle's theorem came first, and then later people realized, oh, this, we could do this, for broader cases, and they came out with the mean value theorem. But I wouldn't be surprised either if it's actually the other way, that maybe the mean value theorem came out first, and then people realized, hey, we're actually using the mean value theorem where the slope, of a point equals 0. Why don't we give that its own name, just so we can reference, that, and that's, a little bit simpler. I'm not really sure which way it is and exactly how this gets used, but there you go. Why Rolle's theorem is a special case of the mean value theorem. Again, one of the joys of math, and I hope you guys enjoyed that as much as I did.